Managing dependencies in monorepos is impossible, or so you think. We'll go through everything I've put on the screen here and a little more, and I think you'll see that the experience is quite nice, even in big repos. Let's start with package managers. We're focusing on practical knowledge for now, so we won't dive too deep on each of them. If you do want to see me do that in a separate video, leave a comment for me so I know to make that. For now, here's a quick chart of my experience with each of the three major package managers after you're debugging so many monorepos. I won't claim to be a package manager guru, but I've certainly had my fair share of messing with each one of them enough at one point or another. There are a few things I want to call out here. On this chart, I'm only showing the defaults. There are various configurations you can apply to your package manager, so you may be able to tune away some of the trade-offs on this chart, but I like keeping it simple, so you're looking at the defaults. Yarn gets two columns for a couple of reasons. The first is that Yarn 1 is so different from Yarn 2, especially if you're using Yarn Modern's plug and play feature. The second reason is that when folks in the Turbo Repo community do use Yarn, I see Yarn 1 the most often by far. So despite its age, it's still pretty relevant. The last thing is something else folks ask me about a lot is, hey, something is installed in node modules where I wasn't expecting it to be, or node modules itself isn't where I expected it to be. Depending on which package manager you're using and even how you've configured it, you can end up with different locations for node modules itself and also the dependencies that you find in node modules. The thing to keep in mind is that your package manager is doing what it's supposed to as long as your applications run as you expect. Now, if you want to know what I use PNPM. It's what we're using at Vercel, and we enjoy it. I find it's fast, it's stable, it has sensible defaults, works great at scale. It's the package manager I have to debug the least when working with turbo repos that community members have sent me, and it has many nice monorepo features. These factors are all important to understand because TurboRepo isn't responsible for dependency resolution itself. When your program goes to look for dependencies, that gets handled by your package manager. So when you see things that look like dependencies not resolving correctly, your debugging will be in package manager land rather than TurboRepo land. Now, let's get to work. First thing, where do I install stuff? This is the most common question that I get around dependencies for monorepos, and it boils down to a simple answer. Install dependencies where they're used. But Anthony, what do you mean by that? Think back to the previous video in this series where we talked about structuring a workspace. We start to think about each package as its own specific localized area in the workspace, and the root of the workspace is a global that can affect all of them. That means changes to the workspace root will cause all tasks to miss cache. At scale, that can be a huge drag on iteration velocity. So let's apply that idea to our dependencies. Ideally, we only put things that operate at the scope of our entire repository in the root. For instance, the repo I have here is create turbo, and in the root, we will see turbo. That makes sense. Turbo repo handles all of the repositories, so that's a sort of global concept. You'll also notice TypeScript and Prettier are here too, and they're here for a very specific reason. The short version is that the language servers for these tools assume they are at the root of the workspace, and not putting them here results in some bizarre behavior sometimes. There are other tools that this applies to being put in the root. Thinking of lint staged is coming to mind, but altogether, you want to keep the amount of dependencies and code in the root small. Again, these are globals that make the repo run, not the packages that make up your libraries and applications. So what do we do with dependencies that are for our library and application code? Well, you install them where they get used. As an example, we have web package JSON here, and we see Next is here. This is a Next.js app. It's our web application. Same idea happens over in the docs package JSON. It looks exactly the same, and we have Next. Now, there's a reason to do this. There are many benefits, actually. First, we vastly increase our ability to hit cache when we localize our dependencies. I'll maybe add is even here. And when I install, we're going to see something interesting when I run turbo build. I'm only going to miss cache for the docs application. This is an improvement, and at scale, this can mean a massive difference in your organization's ability to achieve higher cache hit ratios. You can imagine if this were in the root, we would miss cache for our entire world. Not the best. Second, we only make dependencies available where they need to be. Let's say I wanted to add a Vite application to this repository, and let's say I decided to install that in the workspace root. If I now go, once this is done installing, to a page for our Next.js application, I can import from a Vite application. We can see that I can pull code for Vite. That's probably not what you want. You can imagine the mayhem that I can start to unleash if I do this with more and more developers, more and more code, more and more dependencies. We can end up making a pretty big mess. Third and last, we do get some flexibility here to be able to make more incremental changes when we try to bump versions of these external dependencies. So for instance, it looks like I added is even to the docs app. I'm going to hop over to my web package JSON, and I can now add is even at maybe one of the 0 point releases. I don't remember what they are. Maybe, hopefully that one exists. And when I install, this works. Realistically, there's nothing to say that I can't use different major versions here if I really need to. The fact of the matter is that our docs app may have some reason that it can't bump a version quite yet, but the web app can, and you might have some compelling reason to let these versions diverge. This also lets you make more incremental changes since that version is indeed decoupled. You can make one PR for the web version and one PR for the docs version, and we have the opportunity to keep our PRs smaller, so leaving that opportunity for ourselves can be a nice win. So those are the key benefits of this approach. But I do want to contradict myself a little bit on the last one that I mentioned. You may choose to let dependency versions diverge. However, you do increase the surface area for your package manager to exhibit buggy behavior over time if you start letting too many dependencies diverge from each other too often. So you probably want to keep it to a minimum. But there's also another side of this, poor UX. If I go to my UI package and I start installing another version of isEven, and I bring this into a front end bundle, this will bloat the client bundle. There will be two different versions of isEven that get used on that page or whatever it is for that client view. At scale, this can be disastrous for performance if these dependencies start piling up. Instead, we can introduce a tool called SyncPack. It has one job and it does it well: consistent dependency versions in JavaScript monorepos. I'm just going to try it out quickly with pnpndlx, and it will show me that isEven doesn't have the same version throughout my repository. I can also ask it to fix mismatches instead of list them. This will, as you'd imagine, make everything the same exact version. You can also provide SyncPack with this .syncpackrc.json file, and it will be able to skip certain packages. Maybe you can ignore certain packages while you're migrating. You can add a lot of configuration there to make things pretty powerful. So that all is how you keep as high cache hit ratios as you can. Give yourself needed flexibility in the repository for migrations, but also have the guardrails you need for scale. Let's move to another common question. When do I use the various types of dependencies that you can put into package.json? Now, there's a short answer when it comes to dependencies versus devDependencies, and some folks might not like that I'm going to say this, but it's true. Just do whatever you want. Yeah, seriously, it really only makes a difference in two situations. First one, if you're publishing the package to a registry, your package's consumers will only download the dependencies list, this one specifically. So anything that's in devDependencies gets left out. So that means you only want to put into dependencies the dependencies that are needed for runtime. Stuff only needed for development, leave that out, put that in devDependencies, keeps things smaller. Second one, if you're using a flag like pnpm install dash dash prod. This will omit the stuff in devDependencies. This sounds good at first, but the gotcha here is that the JavaScript ecosystem has a lot of tooling that's needed at build time that isn't at runtime. So some things you need might go missing unless you're really strategic about what you put into which list. Now let's talk about peer dependencies. The idea with peer dependencies is that a package won't install a dependency for itself. Instead, it will use the version of that dependency that the consuming application or library uses. Let's see this in practice. So let's say I want to add Next.js specific bindings to my UI package. Instead of installing Next directly into this UI package, I'm going to provide a range for Next that is acceptable for the consumer to be using. I'm saying that I expect my consumers to be at Next.js 15 or greater. I'll need to run my install command just to make sure that this next step goes ahead and works. So if I go here and I paste in next link code, this is importing link from next link. Remember, I'm in my UI package, you can see here. All I need is to add this href that I've apparently missed, and suddenly I'm using Next.js in this package without installing it directly. This code will work as you'd expect. It will link to the root route there. Now, last is optional dependencies. I'm going to go ahead and just gloss over this because you ain't gonna need it, to be honest. The idea is that your package can install this dependency, but can also work fine without it. Yeah, I don't know either. And there you have it. Now you know how to handle dependencies in your JavaScript, TypeScript monorepo. A bunch of this information is in the turtle repo documentation, so check out durbo.build to learn more. I'll leave that in the description along with some other links. Please do like and subscribe, and feel free to comment and let me know what you think or any questions you have. See you in the next one.